Hi, well, are some of you still talking to me?
No, I don't think so.
Come on, Alec, it wasn't that bad.
Wait, what did you say?
Are some of you still talking to me?
Wait, what do you mean? I
Uh,
thought you, I thought that you asked if there were people talking to you while you were gone. That's
no,
why I
no,
said,
no, 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 no. I gave a test today.
oh yeah, it was pretty easy.
No,
At
we're
least
good.
I
Yeah,
thought
we're
so.
good.
I thought the test was pretty simple.
Okay. Actually,
Simple.
I've graded 3 of them. So one person got a 61, a 75-ish, and a 77 so far.
Was this for your lecture class?
Yeah.
Okay, thank God.
What are you doing in here? Are you supposed to be in here?
Yes, I'm in your
Okay.
lab.
Okay.
I just don't have you for lecture.
No. Sir, I'm sorry. I was under the mistaken impression that I had you on Tuesday.
No, I'm sorry.
Which may explain the strange email I sent to you.
I don't think so, unless I missed it.
You have to understand.
I'm usually good about checking it.
You have to understand, Sarah, on days I give tests, I get a ton of emails. And I could not tell you where my last thing, in any case, no big deal. We doing okay, ladies and gentlemen? How many of you have had your first test? I know you have, Christine.
Yeah, I have my first one in my lecture class today.
Okay. At least I'm on schedule. Nothing else from anybody? Mr. Popovich?
I had an exam today too, so.
How far are you guys at? Where the people that aren't in my class, where are you at?
We just finished mass and volume.
Mass and volume and density?
Mm-hmm.
Wow. Okay.
Professor Shuniak just started chapter 5 nomenclature yesterday.
She's pushing it. That's really pushing things.
We don't do significant figures yet in his class, so it's been an interesting.
Oh boy, who's talking to me?
Allie Turley.
Allie, it's at least you'll have somewhat preparation when he does get to it.
Right. Yeah.
Anything else? And where else are you guys at?
My class
lecture.
Yeah, our exams are next week. We're reviewing chapter 1 through 4 right now.
So you're talking the Survivor Guide, correct?
Yes, sir.
Okay. Good enough.
Professor?
Mariah.
On the test, like the last 2 questions, like
Don't worry about it.
Okay.
Don't worry about it. You're ruining my surprise. Basically, if I put something in the test, I have to make a question. And if I make a question, that question has to have a point value. So that's why those 2 were 1 and 1. This time I'm just giving you the 2 points. Next test, I probably will include those into a question. Okay? Mariah? You want me to grade them, Mariah?
No, there wasn't a question.
Guys, doesn't it sound like she wants me to grade it?
No.
Okay, yeah, that's basically what's going on with that, okay? And I should have explained it beforehand, but unfortunately, I've had a lot of things that have been hitting me this week, and my bad. I didn't even get a practice test out. I did get the practice test out. I didn't get it out in a timely fashion. Okay, we about ready, guys? Mr. Popovich, it's 7:30. I'm tired. Let's get this over. I'm hungry, right? Right?
Yep.
All right. All right, I got to talk a little bit about density. You seeing the PowerPoint up here?
Yeah.
Yep.
Okay, the way this was introduced to you all is through something called the density triangle. And basically, you see how there is a line between density and the mass and between the volume and the mass. Basically, look at this like a fraction. If you have the mass and you have the density and you want the volume, just simply there's a line between the mass and the density, divide the mass by the density, you get the volume. If you have the mass and you have the volume and you want the density, just simply divide mass by volume, you get the density. On the other hand, if you have the density and the volume and you want the mass, density and the volume are on the same level. So those two you're going to have to multiply. So if you have the density and the volume, you get the mass. You can also do it by the label method. Okay? If you have grams in volume and you want the density, well, what are the units of density in? They're in mass per volume. So if you know that the density is in mass per volume, and you know that the mass is going to have to be on top, and the volume is going to have to be on the bottom. So you're going to multiply the mass times 1 over the volume, or you're going to divide it. Okay? If you have the volume and the density and you want the mass, well, the density is in mass per volume and the volume is volume. So if you multiply those two together, the volumes cancel, you're left with mass. Last one. That's the last one's the most difficult one to kind of figure out. If you have the mass and the density and you want the volume, okay? Well, you have the mass, the density is a mass per volume and the mass is in mass. To get rid of the masses and keep the volume, you have to multiply by the reciprocal. When you have a fraction and you multiply by the reciprocal, that's divided. Either way, I don't care which way you use. If you have another way that works even better for you, God bless you. Please tell me about it. Because these things are probably some of the easiest problems you're going to deal with this semester. Are we good about density, guys? Okay. Allie, if you have a liquid, can you measure the volume directly? Allie, have you ever done any baking?
Yes.
Okay, and it tells you to add in a 1/4 cup of oil. Oil is a liquid. Can you measure that volume directly?
Yes, in a baking cup.
In a baking cup. You have a 1/4 cup thing baking, just pour it in a 1/4 cup, and you know you have a 1/4 cup. You can measure volumes. Now, Allie, can you measure the mass of a liquid directly?
If I had a scale and
You
I
had a
put it
scale?
in the cup.
Okay, we're going to pretend, Allie.
Yes,
Are you good at pretending?
sure.
All right, wonderful. All right. So your desk is a big balance, okay?
Mhm.
Now, I want you to go to your kitchen sink, and I want you to cup your hands under the kitchen sink, open the tap, and I want
Okay.
you to get that water, bring it back to your desk balance, and weigh it.
Okay.
Can you do it?
Yes, here.
You can do it? Wait,
Well,
I'm
no,
seeing
no.
the liquid's dripping, it's dripping all the way off your desk. Can you measure the mass of a liquid directly?
No.
So you got to use some sort of container, okay? The way you do it, you put the container on the balance, get the weight of the container, then you add the liquid to it, put it back on the balance, and you get the weight of the container and the liquid. Easy way, guys, to get the weight of the liquid. You take the liquid of the container and liquid, subtract the weight of the container, we have the weight of the liquid. We good with that? All right. Now, usually speaking, when you are doing liquids, the container generally has markings on it. So you can pour the liquid in and you can read what the volume is. So generally speaking, you use something like a graduated cylinder. Put the graduated cylinder on the balance, read the weight. Add your liquid to the graduated cylinder, put it back on the balance. Read the volume, read the weight of the container and the cylinder. Easy peasy, guys. By the way, ladies and gentlemen, this is your exercise, one of your exercises for your final. Okay? You have to get the weight of the density of a liquid. Okay. If I have a container, if I have a graduated cylinder, and that graduated cylinder weighs 32.643, I add in my volume, I read it. My volume reads 10.2 milliliters. I then put it on the scale and it weighs 42.893. To get the weight of the liquid, I subtract the container from the weight of the container and the liquid. That gives me 10.250 grams. I simply divide that by my volume. I get my density. Easy peasy. Is this hard?
No.
Okay, good, good. I like not hard things. Not hard things make my day. Okay, now that I've got a break. Lewis, are you here, Lewis?
Here.
Thank you, sir. Christina, I saw. Nathaniel. Nathaniel going once, twice. Is anybody seeing him in the chat? Okay, Kelsey. Kelsey, going once, twice. Marie.
Yes, I'm here.
Thank you. Donovan. Donovan. Once, twice. Maxwell. Maxwell. Twice. Gone. Armethea. Armethea. Neela.
With an N or an M?
With an N.
Not me. Okay.
Thank you. I've already marked you off. Kaylin.
I'm here.
Thank you so much. Elizabeth. Elizabeth. Malin.
Here.
Thank you so much. Jordan, I think I saw you.
Yep, I'm here.
Thank you, sir. Mariah, I got. Aaron.
I'm here.
Michael.
Here.
Sheridan.
Here.
Alec, I saw. Brian.
Here.
Sarah, I saw. Alexis. Alexis.
What's the last name on that one?
Turley.
Oh, that's me.
Sorry, Allie. I'm sorry. I even have it marked Allie. Thank you. All right, ladies and gentlemen. We've done the density of a liquid. With the density of a liquid, you can measure the volume directly. You have to measure the mass indirectly. What about a solid? Aaron? Can you measure the mass of a solid directly, Aaron?
Yes.
She said very, with not a whole lot of confidence. Aaron, say it with confidence.
Yes.
Yes, absolutely. You can measure the mass of a solid. All you got to do is put the thing on the balance. Wait, read it. Not too difficult, right, Aaron?
Yeah.
Finest kind. Now, Aaron, Can you measure the volume of mass directly?
What?
Can you measure the volume directly of a mass?
Oh, no.
No?
No.
Do you want to bet your score on this report? On your answer right now? You should be very, very unconfident, Aaron.
I'm very unconfident.
All right, absolutely. Like the old man who was choosing his underwear. It depends. I got to laugh out of Allie. Okay. It depends upon what circumstances. Aaron. I got to find myself a block. This is crazy. My whole house, I don't have a block. All right.
Yeah, because
We'll do
everybody
it.
keeps
Wait,
those
one
laying
second.
around everywhere.
1 second.
I have a lunchbox right here. If that helps.
Kids.
A Harry Potter book. Okay.
Good enough.
All right. Aaron,
Yeah.
can you measure the width of this book?
If I had a ruler on me, yeah.
If you had a rule, well, you can't measure it. You can't measure it. I can, but you can't. I have a ruler. Can I measure this?
Yeah.
Can I measure the width? Can I measure the height or the length of the book?
Yeah.
Can I measure the length or the height of the book?
Yeah.
Let's see, Aaron, what do I need to get volume of this book?
Length, width, and height.
So, is it possible to directly measure the volume of a solid?
Yes.
Okay. Now, let's see what I can come up with. Okay. Can you measure that one?
No.
You guys are probably wondering why in the world I have a monkey. That's a monkey. You can't measure this one, right?
Well, couldn't you, if you broke it down by parts, like do the volume of the circle, the ears as half circles, and then his body, and just
Too many
kind of.
dimensions.
Mila, do you have that much time on your hands? You have two kids.
I don't have time for a lot of stuff.
So there are some solids that you can measure. If you have a regular shape, you can get and measure the volume of a solid. If you have something that is irregularly shaped, you can't. But we'll fix that in a second. All right? So if it's regularly shaped, all you got to do is directly perform a measurement. If you have a cube, all you got to do is measure one side. And take the cube of that particular side, you'll get the volume. Block, length times width times height. If we have a sphere, see, guys, that's the top of my desk. I got all sorts of toys there. All right, I have a sphere. Can you measure the volume of this sphere? Generally speaking, you could take a ruler and measure the diameter of the sphere, then divide it by 2 to get the radius. And once you get the radius, you can plug in the formula, 4/3 pi r cubed. Make sense? If you had a cylinder, all you got to do is get the area of the cylinder, pi r squared, and multiply that by the height. And you'll get the volume of the cylinder. Then you've already directly measured the mass. Find out what your volume is using the formula you need to use. Divide the mass by the volume. You have your density. A bar has a length of 7.80 centimeters. a width of 4.75, and a height of 1.45 centimeters. Its mass is 354 grams. What is its density? Well, it's a block, so I multiply length times width times height. I do that math out and I get 53.7 centimeters cubed. Then all I have to do is take my mass, divide it by my volume, and I get 6.59 grams per milliliter. But Mr. Popovich, you just magically turned centimeters cubed into milliliters. You can do that, guys. 1 milliliter is equal to 1 centimeter cubed, which is equal to 1 cubic centimeter. Okay? Questions about this?
I have a quick question. This was brought up in my lecture class. I have Professor Stodden, and he told me that it doesn't matter if it's oddly shaped or not, that you can always measure the volume and density of it. And he gave like a really complicated formula for it. Is that something that we have to do in this class? Because if so, I'm very lost on it and I didn't understand a single word he said.
Mr. Stoddard has a lot of time on his hands. Okay. Can I ask you a question, Sarah?
Apparently.
Okay, Sarah. If I take this monkey, okay, I take this monkey and I take Phil, I have this measuring device that is marked, okay? I put a volume of the liquid in this measuring device, right? I find out how much the volume is. Then I could I put the solid into there. What happens is when I put the solid in, it displaces the liquid to the same volume as the volume of the solid. So how hard is that in comparison with doing this convoluted equation of his?
That's a lot easier. I can definitely manage that a lot better.
Stick with me, Sarah. We'll go far.
I appreciate it.
Got a spot open in your lecture class?
I don't know. Wait until after they get the results of their test before you ask to beg into my lecture, okay?
It's worth it.
We'll see how they do. All right. Okay. Yes, Sarah, it is possible to go through and measure the little ears and measure the little nose and the little feet. It is possible to go through and do that and add those all up and come up with the volume. I find it ridiculous to even attempt that. So what I'm going to do, if I have an irregularly shaped solid, I'm going to determine the mass directly, just like I did before. But what I'm going to do now is I'm going to fill a vessel with water. That vessel is going to have markings on it. So I'm going to fill it. I have to fill it so that it covers my solid. So I'm going to fill it to the level where it's going to cover my solid. I'm going to mark what my initial volume is. I'm going to put my solid in. What the solid do is it will cause the liquid to rise to the same volume that the solid has. So all I have to do is subtract my final volume from my initial volume. That will give me the volume of my solid.
Like
Then
when you fry a turkey.
What's that?
Like when you deep fry a turkey, you got to know where the level.
Or else you're going to be wasting a whole lot of oil.
You're going to burn your house down.
That too. But yeah, I'm sorry. I've seen some turkey fryings that have been rather almost catastrophic.
We put the oil in our fire pit in our yard and lit it on fire, and it like was 3 stories high. It was ridiculous.
I had a friend that raised a turkey, and he literally had a 30-pound turkey, and he was trying to cook it in his Weber. And literally speaking, he lifted the lid off and he almost got his house on fire because the flames were literally just from the turkey grease.
Oh,
The flames were about 5 foot high.
it's insane. We were not expecting it to like explode and like, be like 20 minutes of like 3 stories high.
Absolutely amazing. Okay. Are we buying this? We're not going to go and measure irregularly shaped solids, are we? Okay, Michael, are you gonna measure an irregularly shaped solid?
As long as I'm in your lecture, no.
Are you serious? He actually came up with the formula for this?
Yep.
What was it? Seriously, what was it? What was he measuring?
A waste of time. No,
Pretty
he
much,
was just
yeah.
he was just telling us, he was just like anything can be measured. Like there's no such thing as it not being possible to be measured, but
all right.
It took up like half a class time to do
like,
the
like half
formula.
of our class was just him explaining that.
Okay. I will concede it can be done. I will concede that. All right. It can be done. However, it's not worth 40 minutes of my class to sit there and explain it. All right. When it's just as easy to do Archimedes' principle, which is basically what we're talking about. So guys, hand up to God. Come on, hand up to God. I am never going to measure this. I'm going to use the displacement of the liquid to measure the volume of irregularly shaped solids, except of course when I'm in Dr. Stoddard's class. Okay. All right. So if we have an irregularly shaped object, all right, what I'm going to do is I'm going to fill my graduated cylinder up to 17.8 milliliters. All right. I'm going to take my solid, put that on my balance, and I'm going to end up with 6.543 grams. Then, guys, when you're doing this, if you ever have to do this, like next semester for Chem 1, if we ever get back to face-to-face labs, when you do this graduated cylinder, tip it. Tip it so that you can take your solid object and slide it down gently. For one thing, it won't splash the liquid that's inside it. For another thing, if you go directly down, graduated cylinders are made of glass. If you put it directly down, there's a good chance you're going to break the cylinder. So I slide my solid into my graduated cylinder, and I find the new volume is 25.3. Well, the volume of my solid is going to be the amount of liquid that was displaced. So I have 25.3 minus my initial volume. That gives me a volume of 7.5. I'm then going to take my density, which is 6.543, and I'm going to divide that by the volume I just figured out. And my density is going to be 0.87 grams per milliliter. There's another way that we're going to do densities. I'm not going to really talk about it because it's graphing, and we're doing graphing next week. You actually are next week going to graph a density study, and we're going to be able to do that. So basically, if I get different weights and different volumes of the same substance, the density doesn't change. If I have more of something, the density doesn't change. If I have 5 pounds of gold or I have an ounce of gold, it doesn't matter. The density for the gold is going to be the same. So what I'm going to do is I'm going to measure different volumes of my unknown, and I'm going to find out how much it weighs. and I'm going to do like maybe 5 points. If you plot mass versus volume, you get a straight line. Now, does anybody remember what slope is?
Yeah.
What is it?
Rise
Y
over.
equals mx plus b.
That's the formula for a line.
That's a formula for a line. So what's the slope, Mila?
The m, it's y equal, or it's the rise over run.
Rise over 1. How much it goes up versus how much it goes side to side, right?
Mhm.
So let's think about this. What's the rise going to be in? What is the label of the rise here, Mila?
Mass in grams.
Grams. Okay. So I'm taking the rise, I'm dividing it by the run. What's the label of the run?
The cubic centimeters.
So if I'm dividing grams by cubic centimeters, what is grams divided by cubic centimeters? Mass divided by volume?
Oh, the density.
It's the density. So when I get the slope of the line, that will be my density.
Okay.
Again, I'm not going to get into this. I go through portions of graphing because my HCC doesn't have specifically a graphing lab. Any questions on what I've talked about so far? That's basically what we're doing in the experiments today. So what I'm going to do first is I'm going to go back, and that's the PowerPoint. Okay. I'm going to make sure this is the right class. Yeah, this is you guys. Okay. Are you seeing my screen share?
Yes.
Yeah.
Okay, so we're going to get to course content, and we're going to go down, find the density and miscibility. Okay. What I'm going to do is I am going to show you the lab itself, then I'm going to go down to the results, okay? Okay, so I got to move you guys. First thing we're going to do today is we are going to get the density. Got to find the right place. There we go. We're going to find the density of a liquid. It's just like I said, you're going to weigh a dry 10 milliliter graduated cylinder. All right. Then you're going to add between 4 and 5 milliliters of an unknown liquid to that graduated cylinder. You're going to put that onto a balance. Okay. You're going to record the volume of the liquid, and you're going to record the mass of the cylinder and unknown liquid and the mass of the cylinder. You're going to be able to get the density of the liquid by first finding the mass of the liquid by subtracting mass of liquid and cylinder and the mass of the cylinder. That will give you the mass of the liquid. You then simply divide that by the volume of the liquid. All right. Now, to that graduated cylinder with the between 4 and 5 milliliters, you're going to add another 4 to 5 milliliters to that. And you're going to make sure you don't go over the 10 milliliter line. You're going to put the total liquid and the graduated cylinder back on the balance. You're going to first read the total volume of liquid that's in that graduated cylinder, and you're going to read the mass of the total liquid and the graduated cylinder. You're going to subtract the mass of the empty cylinder. To get the density, you're going to get the mass of the total liquid divided by the total volume. Let's see who I need to talk. Sheridan, you out there, Sheridan?
Yep, hi.
Okay. What those two densities I just told you about, what should the relationship be? Have you changed the liquid? Did you add the same liquid?
I'm sorry, I had to do something with my dog, so I wasn't
Okay.
actually fake fishing. I'm so sorry.
No problem, Sheridan. Maxwell's not here. Kaylin, you out there?
Yes.
Okay, Kaylin. You put the same liquid in the second time.
Mm-hmm.
Should
So
the relationship of the density of the first trial be to the density of the second one?
it should be the same.
They should be the same. You've got the same liquid. Density is not going to change. Okay? Next thing you're going to do, you're going to find the density of a rubber stopper. You're going to take one rubber stopper, weigh it. Then you're going to put about 10 to 15 milliliters of water into a graduated cylinder. And you're going to note what the initial volume is. You're going to put the rubber stopper in. That volume's going to go up. You get the volume of the rubber stopper by taking the final volume, subtracting from it the initial volume. You've got the weight there. You've got the density. Questions about B? C, you're going to do the same thing with an unknown metal. Same exact procedure. You are going to weigh the unknown metal. You're going to fill the graduated cylinder up about 15 milliliters, record the initial volume. You're going to put the metal into the liquid. You're going to record a final volume. Volume of the metal is final volume minus initial volume. You've got the mass already. You have the density. Now, part D. All right. In part D, what's happening is you're doing 3 densities of 3 different liquids. Part D is the same procedure as part A. You're finding the density of a liquid. So each one of these liquids, you're putting between 4 and 6 milliliters into a graduated, you're weighing the graduated cylinder, getting the mass of the empty graduated cylinder, putting 4 to 6 milliliters of that liquid in there, recording the volume, then putting the liquid and the cylinder on the balance. Subtracting the weight of the liquid and cylinder and the weight of the empty cylinder, that gives you the weight of the liquid. Divide that by the volume, you have the density. Okay, you're going to do that for liquid A. Then you're going to dump liquid A out, and you're going to do the same thing with liquid B. You're going to dump liquid B out, and then you're going to add liquid C to it. So you're going to have 3 different densities of the 3 different liquids. The next thing you're going to do is you're going to a large test tube, you are going to put the most dense liquid in there. And this is going to be like, for those of you that have had an adult beverage in your life, this was like pouring a layered drink. Has anybody ever had a layered drink?
Yes.
Okay, this is the same thing. You're going to put the most dense liquid in the bottom of the test tube. The second most dense liquid, you're going to carefully pour that so that it slides down the test tube side, and you're going to end up with 2 different layers. Then you are going to put the third layer in there, the least dense liquid. So eventually you're going to have a test tube with 3 distinct layers in it. Has anybody ever mixed salad dressing? Andrew, you ever done that? Andrew?
Yeah, I have.
All right. Have you ever let it settle out?
Yes.
Does it settle into 2 separate layers with like a line between them?
Yeah.
So this is the same thing that's going to happen with these 3 liquids. So that's the entire experiment, guys. So now what I'm going to do is I'm going to go back out of here and I'm going to show you what you're dealing with in the actual all right. This is part A. The first one, you have to look at the triple beam balance and determine the weight of the empty graduated cylinder. Then what happens is for trial 1, you dumped in this much liquid volume. Put that back on the scale. The weight obviously increases. You're going to subtract the weight of the liquid and cylinder from the weight of the cylinder to get that mass. You're going to divide it. You're going to read this. You're going to read that volume and you're going to divide it by that. Now, remember what we did with that experiment. We then took the graduated cylinder and dumped more of the same liquid in there. So if you notice, the volume has increased. So has the mass. Now, to get the mass of the entire thing, you're going to subtract the total weight from the weight of the empty cylinder and divide it by the total volume. Questions here, guys? Anything? Second part. We put the rubber stopper onto the balance. We read what the weight is. We put the liquid into the graduated cylinder. We're going to read what the volume, what the initial volume is. Then the cylinder on the right is the volume of the liquid plus the rubber stopper. So you're going to subtract these 2 volumes to get the volume of the solid, and you're going to divide that into the weight of that rubber stopper. Same thing with the metal. We're going to weigh the metal directly. We're going to put an amount of liquid into a graduated cylinder, add the solid to it, the volume goes up. So you are going to have to subtract the 2 volumes to get the volume of the solid, divide that into the mass. You have your unknown metal. I don't want to belabor the point. Okay, part D, this is going to be the weight of your empty graduated cylinder. Volume and weight of the liquid and graduated cylinder for liquid A, liquid B, and liquid C. Find the density of all 3 of them. Now, I got to show you the lab video, all right? Because you have to see the liquid, the colors of the liquids. After you get the densities, remember I said we're going to do the layer thing. Most dense that goes on the bottom, second most dense, lightest. Okay, where's that at? Okay. I've got to stop this. And I got to try and share screen again.
So what Carly's going to do here is she's going to weigh this graduated cylinder.
I know
she's
it's too
making
loud.
sure that this will end up being balanced. Now, when she did this,
That
she
better, guys?
assured that
Are you
the
hearing it?
20 there was in the notch at the back.
Kaylin, you're hearing it?
And now she's moving
Okay.
Yes, we're hearing it.
All right. If you want to go through the video, it's a great way to understand what's going on. Okay? This is mainly what I wanted to show you.
So what we're looking at here is part 4. The densities of the liquids have been found and they've been put in this test tube most dense to least dense. There's the most dense, there's the second most dense, there's least dense, and you can see the phase differentials here as well. So we're going to add a bit of iodine water to this, just 5 drops. Kenan, would you please add 5 drops of iodine water? So just adding it in through the top of the test tube here. Okay. Now what I'm going to ask him to do is to go ahead and swirl a little bit. So now what's happened is we've added the iodine water. Kenan has been swirling it quite diligently. And what you can see here is the final effect. We've got, you can barely see it, but there's purple, that's yellow, and that's purple on the bottom as well. Could you just hold it up just a little bit? There we go. And you can see the purple
Trust
on the
me,
bottom there
guys.
as well.
If he would have
Right, thank
shaken this a little more, it would have looked purple or pink, purple, pink, brown, purple, pink. All right. Now.
We just had the.
Crap. How do I get the old one back? Yeah, there we go. Skip trial. All right.
Quite diligently.
Okay. Now, Marie, does the bottom layer mix with the middle layer?
No.
Does the middle layer mix with the top layer?
No.
Does the $50 million question, does the top layer mix with the bottom layer? Can it?
No.
Seems like.
How do you know? Has the top layer ever seen the bottom layer? It's separated by the middle layer. So do you know at this point whether the top layer will mix with the bottom layer? Do you know?
No, you don't know.
No.
Not
Okay.
until you measure the density.
Well, it doesn't matter the density. The density is, well, Christina, it doesn't matter whether one's on top of the other or the other's on top of the other one. The densities don't really matter. If they're the same, you get a big mess. But the densities aren't the matter. What does matter is, remember, we put iodine in this. And we got the top layer to dissolve the iodine so that it looks purple, pinkish. Same thing happened with the bottom layer. So they're reacting, they're dissolving iodine in the same way. What do you suspect? Do you suspect the top layer and the bottom layer would mix? Christina?
Yes, yes.
The properties are the same. So there's a good chance that they both will mix. And actually, when I do this experiment in person, what I do is I take this 3-layered liquid, I shake it up, and literally what happens is the 2 layers mix. So that is true in effect. Okay. I want to get rid of this. There we go. It's gone. Okay. I got 10 more minutes. I want to go through the post lab real quick. Let's go through the results real quick too. Oh, I have to do this. This is all right. Now, ladies and gentlemen, when you are doing the lab report, you're doing something, the same thing that you did last week. You're taking the text boxes. Question 1 asks you to calculate the mass of the unknown liquid and the density. I want to see all work in the text boxes for that. 2, second trial of that determining the density. What was the average? Next question. Determine the volume of the rubber stopper, calculate the density. Again, from start to finish. Remember in the text boxes, I need you to do the sig figs right. I need you to label them with a unit, and I need you to label them with the description where the number came from. You're going to do the same thing for the metal. By the way, your code number is 162587. You have that? I don't actually believe Kaylin's actually writing that down.
Can you repeat that? 162567.
578345. Or was it 6215843? Put any number in there. You get 10 points. Put a number in there, you get 10 points. Okay, you're gonna have to do the density of that. And this is where you do the density of all 3 liquids. Now, you're gonna have to say which is layer 1, which is layer 2, and which is layer 3. If you think layer C is layer 1, put the 1 there. If you think B is 1, you put the 1 there. Now, it asks you the next question, what are the colors? You're going from 1, you're doing 1, 2, and then 3. That would be a good choice, but I didn't say anything. Last thing, you have a couple of post-lab questions. Okay? A sample of 175 milliliters of liquid orange juice has a density of 1.20 grams per milliliter. When frozen, the sample has a density of 1.10 grams per milliliter. Calculate the mass of the liquid orange juice. Lewis, you out there, Lewis?
Yes.
Okay. We have a density and we have a volume. How do you calculate mass, Lewis?
You would do
Okay, Lewis. I want you to look at the labels. We have a volume here, right? Right,
Yes.
Lewis? We have
Yes.
a grams per milliliter here. What are we going to do with these two numbers? Because we want to end up with grams. What are we going to do with those two numbers?
So you would multiply them.
Multiply them. Okay. Now, Lewis,
Yes.
which density am I going to use? The 1.20 or the 1.10?
I would say the 1.20.
Because it's the liquid orange juice. And that's what you want. Now,
Okay.
what happens is you freeze that mass of liquid orange juice. When you freeze something, does it lose mass or does it gain mass? I know you're tired.
Doesn't the mass stay the same?
Mass stays the same. But we need to figure out what the volume of the solid orange juice is. Now we have the mass and we have the density of the solid orange juice.
Where's the density of the solid orange juice?
It's in the previous problem,
Oh, gotcha.
0.110.
Oh, okay.
So if we have the mass, we're going to divide it by the
New density.
density of the solid. Okay. What do you suspect is going to be, if you compare the volume of the solid and the volume of the liquid, which one do you think is going to be bigger?
The liquid.
The liquid is, wait, I have to sit here and think. No.
Yeah, there's a lot of water in orange juice, isn't there?
Yes, there is. No, the liquid does not. What did you say, decrease?
Honestly, I have no idea. I forget.
All right. If you have the mass, let's think logically. If you have the mass and you divide it by 1.20, you're going to end up with 175, correct?
Mhm.
Don't yawn on me, Christina. Would you agree, Christina? If you have the mass and you divide it by 1.20, you will get 175, right?
Right.
If you have that same mass, but you're dividing by a smaller number, is the volume going to go up or is it going to go down?
Go down.
You're dividing by a smaller number. Okay. All right. You have 8, Christina. Do this math for me. You have 8 divided by 4. What does that give you?
2.
You didn't use a calculator. I'm impressed.
No, I've been doing calculus all day. So,
all right. So what I'm going to do now is I'm going to divide 8 by a smaller number. I divided it by 4 and got 2.
Yep.
If I divide it by a smaller number, what's my answer? By 2, what am I going to get?
4.
So if you divide
Makes
by
sense.
a smaller number, is the volume going to go up?
Up.
So you are suspecting that the volume is going to go up. So did it expand or contract? In other words, did the volume get bigger or did it get smaller when you froze it?
Expanded.
It expanded. All right. Does this make sense?
Not really.
No?
No, I mean,
Christina, have you ever gone into McDonald's?
yes, unfortunately.
You poor thing.
Unfortunately, yeah. My
right.
lifetime, yes.
Have you ever gotten a Coke in McDonald's?
Yes.
Do you put ice in your Coke?
Yes.
Does the ice sink to the bottom?
No.
What does ice do?
Floats.
Okay? So what's gonna, is the mass doesn't change.
Yeah, yeah, it makes sense. It makes sense. I get it.
If the mass doesn't change, then for the ice, the volume has to get bigger because it's less dense.
Right. Okay.
Okay? This one goes to the questions I was raising with the 3 layers. It's asking if the layer liquids A and B, it's asking if they're miscible or immiscible. It's going to ask the same thing for B and C. Then, with the knowledge of the iodine that you've added the 2, it's asking you whether you think A and C are going to be miscible or not. An hour. I did it in an hour, guys. Any questions?
I don't think so.
Now, I should take roll right. No, I'm not going to take roll. I still have 16 people in here. Wow. 1, 2, 3, 4, 5, 6, 7. That's right. Nobody left. Good God, people. Don't you have lives?
You want to learn?
I have a question.
Okay.
I really need to pass your class to get in my program, so no, I'm not going anywhere.
Okay, somebody had a question.
Yes. What's the difference between miscible and homogeneous?
Okay. All right. When you talk about solids and liquids, you generally say it's soluble or insoluble. Okay, Marie?
Okay.
If you have like sugar and water, right? You say that the sugar is soluble in the water.
Yes.
But if it doesn't mix, you say it's insoluble. If you try and put sugar in gasoline, not that I would mention this for an old boyfriend that you hate to put it in his car, but if you put sugar in gasoline, it doesn't mix, right?
Oh.
But because we're dealing with a solid and a liquid, we use the terms insoluble and soluble. Okay?
Okay.
When we're dealing with 2 liquids, we just use different terms. If the 2 liquids mix, we call them miscible, which kind of makes sense. Mixable and miscible sound almost alike, right?
Mm-hmm.
So if they mix, are they homogeneous or are they heterogeneous?
Homogeneous.
Homogeneous. It all looks the same, right?
Mm-hmm.
On the other hand, if I take something like gasoline and water, do they mix, Marie?
No.
They don't mix, so we call them immiscible. So that's the only difference between the 2 terms. When we're dealing with soluble and insoluble, it's a solid and a liquid. When we're dealing with 2 liquids, it's miscible or immiscible. Just a semantic thing.
I got it. Thank you.
All right. Anything else, ladies and gentlemen?
Yes. In the previous question about the frozen juice expanding or contracting, there was something about it breaching the container or something like that. What is that about?
Have you ever put something, filled it to the absolute brim?
Okay.
In a Tupperware,
Understood,
and you put it in the
yes.
freezer? It's because water expands when you freeze it.
Okay.
The mass doesn't change. Mass doesn't change. So when you are changing it, the density does change between a solid and a liquid. If mass doesn't change, then the volume has to change.
Understood.
And what we were doing in that problem is the density of the liquid was 1.2, the density of the solid was 1.1. So if the mass stays the same, whether it's liquid or solid, and we divide it by the larger number, this means that the volume is going to be smaller because you're dividing it by a larger number.
Okay, thank you.
Anything else, guys? Anything about your lecture that you need explained? Remember, I'm here for that as well. If you're having troubles with a concept, I'll be happy to explain it. You guys don't like me. You don't trust me, do you? If you got nothing, then I will see you next week, guys.
Have a nice night. Happy weekend.
Next week is
Have a good night.
exciting. Graphing next week. Yay!
Do you need graph paper?
You can, okay. That was a question, Mila.
I'm sorry, everyone.
Now, guys, you can leave.
Okay.
You can leave. If
All right,
you
have a
want
good
to.
night.
Yeah. I gotta get crap. Okay, I gotta get back into here. It's real easy, Mila. Stop share. Okay, share screen. Let's do it the easy way. I can't believe that guy spent half a class talking to you about measuring an irregularly shaped object.
The worst part about it is he talks in a very monotone voice, and it's at 10:30 in the morning.
Are you saying I'm not a monotone, Sarah?
No, but you keep my attention.
That's one thing I've never been accused of, is having a monotone. Okay, Mila, we're back into the course. You're going to go to course content. Okay, and let's go begin here. Nope. Solve this addendum. No. Guys, if you want a periodic table, here's a good place for one. Okay. Okay, graphing lab. Crap. I swear he used to have graph paper in here somewhere.
Do you have like printable graph paper on
Yeah.
there?
Yeah,
Oh.
just. Okay, what you're gonna have to do. Go to the graphing lab, Mila,
Okay.
and you're
The
going
lab
to
report.
go to the lab report. And you're gonna have to print out the specific page.
I usually print the whole things anyways, just to,
Well, if you need extra though.
okay, gotcha.
You can also go on Google and find, like, if it's like a specific
Grid.
yeah, thank you. I'm so tired right now. I'm so sorry. You can pull it up on Google and print them off because I need that for another one of my classes too.
All right, cool.
But it has to be at least this small. Okay. I don't want the major blocks.
Okay.
So all you got to do is print out page 10 of 16. And if you need extra copies, Mila, he does provide 2 when you print out the thing. He does provide 3 pieces of graph paper if you just print it out straight. Okay.
Okay.
Where are the kids?
Sleeping. I fell asleep with them. That's why I was
Wow.
yeah.
You're blessed.
I know. It was a long day today. A lot of running around with no nap.
Oh,
Oh,
Yeah.
girl, please stop giving me nightmares right now. I just found out I'm 6 weeks pregnant. Don't give me that.
Sarah, Sarah,
Yeah.
Sarah,
Our blessing.
Sarah,
Uh-huh.
be careful of the chemicals that you get exposed to in here.
Yeah. What you're eating, take your prenatals. Try to
Yeah,
be-
I'm
No,
being very cautious. I have
I-
endometriosis, so I have to be extremely careful already. And I'm already taking a bunch of stuff right now, just trying to keep the pregnancy. So
Well,
One
that's-
of the experiment, if we were doing this class face to face, Sarah,
Oh,
I would literally tell you not to come to one of the labs.
yeah.
Because one of the labs, we are working with lead nitrate. Lead nitrate,
Okay.
if you remember what Flint, Michigan's going through,
hmm
this is even worse because it's water soluble lead, which goes literally, think about it, your whole body's made of water. Once
Yeah.
it gets into your body, it gets distributed, goes right through the placenta wall into the fetus. So just be careful of when you get to Chem 1. If you were here for Chem 1, be careful of what you're dealing with, okay?
I only have to take intro to chemistry for my program. I don't have to take Chem 1, but I'm sure there's probably going to be some chemicals once I get into my program that might be a problem.
Changing like cat litter and stuff. You shouldn't be changing litter boxes and everything.
Yeah, my boyfriend's taking care of all of that right now. He's actually doing the majority of everything because he won't let me touch anything because we've had 6 miscarriages in the past. So
Wow.
hopefully lucky number 7, this
Good
will
luck
work.
to you. Good
Yeah.
luck
Thank
to
you.
Sarah.
Thank you. Have a good weekend, everybody.
Ladies and
Bye. Have a
gentlemen,
good night.
that's all I have. So I will see you next week.
See you Tuesday. Have a nice weekend.
Yes, sir.
Take care, Ellie.
Okay.
Good night.
Good night.
Good night.